Give you guys, I'd set up the deal to go live at around 12:30. I'm going to give it a few minutes, give you guys some time to actually jump in and join. Let's see. Let me make sure we got chat turned on. Live chat. There we go. Okay, I'm going to go ahead and tell you, I'm going to give you some tech things here and there throughout this whole deal. Little tips and things, the type of stuff we run into. Hey, John Frank, good to see you, sir. So I will be doing some tech along the way with this, but I'm going to be honest, folks. I'm going to be focused on what I'm doing. So let's get through a couple of the things, and I won't be able to look at the chat too much, again, because I'm going to be focused on doing these heads. I typically don't like being interrupted, but we'll take a break along the way. You guys have seen a ton of videos on doing twin cam stuff. You haven't seen me really do anything on Evos. Of course, we're getting started on the shovel head series, and we're going to be doing head work and all kind of crazy stuff with that one. And then we're also looking at possibly doing a series on pan head as well, because there's a lot of overlapping procedures between pan, shovel, and Evo. So that's pretty cool. Hope you guys caught the video from last night getting started on the crank. So I want to say hey to a bunch of folks. John, Stephen Richardson, good to see you, buddy. Brian Webb, Matt Pelletier, Greg Miller. John, good to see you. Mike Farber. I don't know. I think I've got about 45 or 50 sets of heads in total for various builds, and several guys that popped up are members here. Your heads are in line here and everywhere else. So this is basically just another set in the backlog here that we're trying to get done. So a couple things I want to go over first. Where we're starting, this is not a hot rod build, okay? This bike is one you may see pictures of. It's the one, it's an Evo Softail that we're kind of doing a knucklehead tribute bike, if you will. So we've done the correct and proper year correct Springer front end, rocker fender. We're putting a spring seat on it and all that type of stuff. And also a paint job that would be I can't remember the exact colors, but it's kind of a teal and cream color that was used in 1938, also with a proper tank badge. So it's going to be a really, really cool bike. So what we're doing engine-wise is it's relatively simple. We're just doing a 10th thou over, keeping the compression relatively low. And after I do the valve job, I'll see where the chambers come out. And but my target, I want to keep this thing below 9.5 to 1. So we're going to be somewhere between 9.5 to 1. It's just a very nice cruiser type bike. But let's go over a few things on the heads here. First off, you'll notice they, wrinkle coat. We decided to black out the engine entirely to kind of a tip of the hat, if you will, to the old cast iron stuff. So we're not highlighting the fins or anything. But I want to show you guys to define a good powder coater. First off, we're fortunate enough that we have one of the best powder coaters in the business not too far from here, Miller's Powder Coating. Funny little thing, Bill Miller, who started it back in the mid-'80s, he used to be a commercial airline pilot. And he heard about this newfangled thing called powder coating, paint that goes on like powder. And so he thought it was an interesting business to be in. So he opened his powder coating shop in the mid-'80s, and he's been going strong ever since. But to give you an idea of what good powders, yes, Stephen, watch out for those pilots. What good powder coaters will do. First off, notice several things. How well this area is masked. How well it was masked off here, right? Then we start looking at other things. He took the time to mask inside here where the exhaust gasket goes. He also, I left this tape on here just to show you guys, it's heat-proof tape, but he goes through the trouble of masking off all these holes here. All too often I'll get stuff in here that's powder coated, and these areas will be powder coated, and that's a big no-no. So customer ends up paying a lot extra for me to put this head on a mill, spot face all these powder cut off so we can get proper torque on the bolts and all that stuff. So Miller's does take the time to do things like that. All right, so the other thing you'll notice, we want to go over some porting stuff. All right, so you'll notice these ports, it has been CNC ported, but I want you to notice like this area right in here, I'm looking at the camera to try to see it. Notice how it is not cut. So basically the cutter didn't touch there. Also on the exhaust port, you'll see that basically there's certain areas like there on the back and the top of the port that the cutter hit, but areas in here that it did not. And this is for a couple of different reasons. First off, there is a thing called core shift. These are sand casted, and every head can be a little bit different. So when it goes in a CNC machine and that cutter's in there, if the core shift in the head is off by a few thousandths, then the cutter's going to be off, right? So that's one part. Two, because of the style of this engine, as I said, you know, most of the engines that we build, most of them are different. So on this one, it's all about low end torque. And so a big port wouldn't yield that for us. It's not a hot rod build. So all we wanted to do was basically lengthen the top of the port a bit just to get a little better flow, a little better CFM through there. And then at the bottom of the floor of the port is actually on Evos and really twin cams for a good street build. The floor of the ports are actually pretty good. So they've got a nice ramp up and a nice curve down to get the velocity up and make that short turn. And so we didn't want to oversize the port, compromise the low end torque for the sake of just cleaning up the port 100%, right? But what we will do, once I do the valve job and set the throat and all this for the different on the seats here, I will go in, and I think we'll have time to do that. I will go in by hand and blend the seat into the port, and all of these areas, like again right there, all of those areas right there, I'll blend the CNC area in just so it's a nice smooth surface. I'll blend that into the areas that it didn't cut, and it'll make for a nice set of heads. Now the other thing I'm doing, I say a little bit of an oddity on valve sizes. I'm going to use an inch 900 on the intake side, but I'm going to keep the exhaust valve relatively small. I'm only going to use an inch 570 on the exhaust valve. And a lot of twin cam builds, you'll see inch 610s, inch 635s, and even bigger. Well, there's several reasons. One, again, the idea of this build is to focus as much torque as we can in the lowest RPM range. So a smaller exhaust valve will help do that. The second thing is because of the style of the bike. You know, I like to think of the total motorcycle, right? So with the style of the bike, he's going to be running relatively open exhaust that were characteristic of that era. So there's not going to be a bunch of baffling in the exhaust either. So that said, if I can keep that exhaust valve a little bit smaller and choked up a little bit, then the reversion effects won't be as prominent with, say, a drag pipe or a larger, shorter pipe that you may have seen from that era. So that's the other reason for running the smaller exhaust valve. And plus, on that valve, I'm going to cut the seat a lot wider than I normally would. And believe it or not, a little bit wider contact patch on that valve will help mitigate a lot of heat from the exhaust. You essentially, with more surface area, you have more dwell time effectively of that valve on the seat, and it helps transfer heat a lot better. So engine will run cooler. Does all that make sense? I'm going to blaze through some comments here, and then we'll get started. Bushy the Bird, glad you're here. John Etchels, good to see you, sir. Stephen, you're there. Dewey made it. Awesome. Mark, glad you made it, sir. Camille, I think I'm saying that right. I'm not sure how you can support the channel from Europe, sir. I can look into that for you and get back to you, and thank you for asking. I greatly appreciate that. Mike Farber, Greg Miller, good to see you, sir. And then we're back at it. All right, so some of the other, I'm going to be moving the camera around a bit with all this. So some of the other things we need to do, and I don't want to bore you guys to death, but please understand I do have to get work done. So one of the things with powder coating, also, I'd mentioned all this is masked off. Well, it leaves little edges right along the edge, and we want to make sure that we don't have any gasket leaks or anything like that. So I'm going to be filing off all of these edges, and I'm just going to let this camera run throughout the course of this. So basically, I'm going to outline the process right now. If you guys need to take a break and leave and then come back later, that's perfectly fine. So the steps of the process will be, first, I need to file all these edges. I need to remove the masking. I will then measure the bores for all of the valve guides. I want a very specific interference fit. So I need to measure all of those, make sure I don't need to oversize or hone the valve guide bores. From there, I'll find a matching valve guide. I keep my valve guides in the freezer to shrink those guys up. The next thing I'm going to do is these are going to sit on a hot plate for a while, and we're going to heat them up again to grow that bore. We've shrunk the valve guide. I want to be as least intrusive as possible when I air hammer those guides in there. You can use a press, you can use an air hammer if you want. You just have to be very careful. It's one of those technique things. Basically, I want to preserve that bore as much as I can. In the future, if for any reason someone had to go in and do something, I want it to be serviceable later. So I want to be as least intrusive as possible. All right. So after we then put the guides in the head, I'll put the heads in front of a fan and let them cool down to room temperature. Most measurements in automotive and motorcycle machining, it's kind of the referenced off average room temperature of around 70 degrees. So I'm going to put them in front of a fan, let them cool down, check them with an infrared temperature gun, make sure they're at that 70-degree mark. From there, we go to the valve seat machine, which is this machine right here. And we'll set up the valve seat machine. I will measure each valve stem. Then we'll set up a comparator gauge so I can verify my valve stem to valve guide clearances. And we don't make assumptions there. Remember, there are manufacturing tolerances with everything. So we have a small setting fixture that we use to then set that comparator gauge for the valve guides. Then we measure each valve guide. We ream them. And if after reaming they come out perfect and they have that desired fit, basically I'm looking for 8/10 fit on the intake side and 1.2 on the exhaust side. Exhaust is going to get a little hotter, grow a little bit, so we need to make a little more room for that. If I have those dimensions and my finish after reaming is correct and proper, then there's no need to really hone that guide. But understand, I'm using manganese bronze valve guides, but I'm also using a reamer that is specifically designed for that purpose. So, so that's the short of it is, you know, if they came out perfect and they're perfectly round and square, then we won't have to hone those guides. So again, it's one of those delicate touch sort of things. So once we then ream those guides, that's when we move to start doing the valve job. We'll do the intake first. We'll do the exhaust first. We'll do both intakes, front and rear head. Then we'll flip, readjust the machine. Then we'll do the exhaust side. So you guys, hopefully we'll get to see the entire process. I'm not sure if we'll have time to then CC the combustion chamber of the head. I'll have to do a little math, see where my compression ratio is going to fall based on the piston that I'm using. And that will tell us with a little more math exactly how much I need to cut off the deck of this head here, and that's done over on my lathe. I made a setting fixture for that, and then we mount the head to that setting fixture and machine the particular amount that we need to machine. You can also, you don't have to do that step on a lathe. Some people do it on a mill, and that's perfectly fine with a large fly cutter. I just have a preference of basically producing a phonographic finish so that it bites really well into the Viton coating that's on the MLS head gaskets. And I like that phonographic finish. And I also find I can maintain a little bit better control over the finish itself when I'm doing it on a lathe versus doing it on my mill. So that's pretty much the process. I'm going to check a couple of comments. You guys can tune in, tune out. And between each step, I'll check the comments. Other than that, just sit back and enjoy. Before I get started, do we have any questions? Thank you, Matt, very much. Want to learn, but without distracting. Thank you, sir. Daniel Bates, good to see you. Daryl from Thomasville, hello, sir. Double Dog Blitz, glad you're here. Bushy the Bird, thank you for coming. And so, guys, not ignoring you, but I got to get work done. So let's get started. I will try to talk a bit while I'm doing a lot of this. Chris, thank you, sir. Getting old. Where are my glasses? Getting old. Isn't that terrible? All right. And you know, like if you know, obviously when I put this on the lathe, this would cut this away. The reason I want to do it here is because I have a platen on the valve seat machine, and I want to make sure that this head is perfectly flat on the valve seat machine. And also, when I go to size the chamber, I want to make sure I have nothing that's you know, that's going to keep it, make it off. It needs to be perfectly flat. So we want to make sure all our surfaces are good to go. And now is just a good time to do it. If we were running a compression ratio higher than, say, 9.5 to 1, I would machine this for compression releases just to help save the battery and the starter. It's always a good idea to do that, but again, we're building this one to roughly about 8.5 to 9 to 1, so so it's not a huge critical. There's no reason to put compression releases in it. The other thing, if you ever find yourself doing this filing, you want to hold the file, basically reference the file flat, and just put a slight tilt on it. All right. You don't want to put a hard bevel, but the biggest thing is the direction that you're filing. All right. You don't want to file against it because you can chip the powder coat off, and that's the other bonus of filing this stuff down and putting that slight edge on it, is that it's just enough to potentially keep that powder coat from flaking on you. So I don't know if a lot of you saw that post that I'd put up a couple of weeks ago about the building getting struck by lightning while I was on the mill. I've always had a bit of a rule that I don't operate any of the equipment while it's lightning outside, and I got very lucky a couple of weeks ago. I was in the middle of doing an operation on the mill, and lightning struck the building, and you'll probably see here in a minute the main electrical panel coming into this shop is only about 5 feet from my mill. So sparks came when it hit. I felt the static electricity right before it hit. I felt it, actually the hairs stand up on the back of my neck, which was pretty crazy. And then I looked down at my arms, and the hair was standing up on my arms. And so I jumped back from the mill, and at that moment, sparks flew out of the out of our breaker panel, and there was a loud crash and boom and all that stuff. And fortunately, none of the equipment was damaged, or any of my equipment was damaged. And so I got lucky. So that being said, we had a real nasty storm in here yesterday. They're expecting some more nasty weather today. So I'm hoping that that doesn't happen so I can get these done. But if we start getting some thunder boomers, guys, I'm going to shut the equipment off and unplug it. And then probably what I'll do, I know there's going to be a lot of you guys that have to jump in and jump out and such, and this is just going to be a a ridiculously long video, so I will probably, I don't know, 2 or 3 weeks when I have time, I might go back and download this video and then edit it and just cut out this type of stuff. Another thing you'll notice, I'm just kind of carelessly spinning this head around on my workbench. I know I will be resurfacing that deck, so I'm not really overly concerned about scratching it or anything. But if you were working on a set of heads and you were not planning on resurfacing the deck, then I definitely wouldn't do that. I would protect it with, put down a microfiber piece of cardboard or something. Of course, you'll notice my workbenches. I'm not a big fan of stainless, only because this is actually floor tiles, and they're sticky back, and they're a bit softer. Won't damage aluminum or anything like that. So definitely don't use carpet. I've seen people do that and rubber, because it, I don't use that because it can trap particulate and scratch things. So I like using these peel and stick 12 by 12 tiles, because when I wear one out, then all I have to do is peel it up, stick another one down. Works pretty good. There we go, a little bit more. All right, now the next thing we want to do are measure these guide bores. Now, with anything else, cleanliness is next to godliness. So I love brake clean. We go through a tremendous amount of brake clean around here. I'm going to clean these bores out really well, and then grab a comparator gauge, measure them, and I know what they're supposed to be. And as long as they are below the minimum, if you will, or maximum, maybe that's a better way to say it, below the maximum, then I can run a standard guide. If not, I may have to run a half, a 1, 1.5. And I'm also going to check to make sure that bore is not tapered. It should not be. These we take special precautions when we remove them, so they shouldn't be tapered or barreled. Too bad. And if that's the case, we can save ourselves the trouble of having to bore or hone these. All right. I think you guys can see everything. All right, there we go. Let's see where we're at. All right. Excellent. Well, that one we're 1 thou under where we 1 thou under our maximum. Check on the different axes. We've still got a round bore. Now we're going to go a little deeper. And we've got a perfectly square bore. Actually dead on the money, at least within a thousandths. Let's see. Oh man, we're perfect. Dead on the money all the way around. So let's check this one. Yep. Same. Same. This is an important step, making sure you don't have taper and all that type of stuff, because and you got proper fit. Obviously, you don't want the guide to slip. And the other part is oil migration. You know, you need a real tight fit in there, so when you shut this thing off as it cools down and stuff, it doesn't draw oil between the guide and the head. All right, this one is perfect. Excellent. To here. Man, these things are perfect. Yep. And I'm not a real big, you know, no-go gauges. That's another way you can do this. Basically, it's a slug of metal machined to a particular size, and then you try to slide it through. If it goes, it's too small, that sort of thing. Most of you may know what a no-go gauge is. It's good to confirm, but I like to be able to measure finite points in 4 different places. And when you use just a no-go gauge, sorry, you can't really do that. So with this method, I get to see, you know, both axes and then on 2 different planes, just to make sure, again, we don't have that barrel in there. Perfect. All right, perfect. Yep, we are dead on the money. That is great news. All right, the next step is, let me move the camera here. A commercial hot plate, believe it or not. So I have pretty good control of the temperature here. Again, I have my guides over in the freezer, and they're doing their thing. So let me grab a drop cord, plug this in, and then the next thing we're going to do is I'm going to show you guys the comparator gauge. We're going to go ahead and set up our valve stems, measure them, set up our comparator gauge for that while these are heating up. We'll do that, and then we'll also set up our cutters. I actually like to use carbide cutters with the profiles already built in. Because of this type of build, we're going to do just a really nice 3-angle valve job on the intake, and then on the exhaust, we're going to do a single angle with a radius. Okay, so yeah, we're going to do single angle for your contact patch for the valve there, for the seat itself, and then a radius into the port, and then I can blend that in by hand really nice. So let me check some comments here. Massimiliano, I wonder if I said that right. Good evening from Italy, sir. Nice to have you. David, you may have, no one else is making comments about bad reception. It looks good on my end. It might be maybe your connection on your end. I guess everybody's doing okay. Let's see. Everlast Tig in the background. Yes, sir, you do. I just picked that up not too long ago. Love that machine. Let's see. Your weather will be there about 5 p.m. That stinks. Thanks for the heads up, Daryl. I appreciate it. Hopefully we can get as much done as possible. Let's see. Truck drive furniture. I think it's anti-reversion chambers and exhaust and baffles other than straight with more restriction. It depends. What he's asking about is running either anti-reversion cones. Some people call them torque cones. Sometimes they work. Sometimes they don't. I've seen it both ways. It's almost a trial and error thing. Randy, hello, sir. Good to see you. Easier on your mill. Learn something new every day. Yeah, good to see you, Rich. Have any recommendation? I approve low end torque on mile 128. That's a long answer to that, Camille. Sorry, but we're going to keep rolling. If you want to shoot me an email, Daniel Bates, thank you for the kind words, sir. Chris W., you're the man. Thank you. Mick Rose from Australia. Cheers, mate. All right, guys, let's keep going. Let me go grab an extension cord. We're going to get this plugged in. Actually, let me do this the easier way. Y'all hold your ears for a minute. Hey, Junior! Can you grab me another extension cord? I've got one plugged into the camera. There should be one over in the shop. We should have extension cords around here everywhere. So, all right. So now I'm going to show you how we set up the setting fixture to size the valve stems. We do this for each set of heads we do. We don't just assume the stem is going to be the same size. Most of the time, yes, they are. However, we're dealing in tenths of a thousandths, right? I mean, we're 4 decimals or 4 digits to the right of a decimal point here. So there can be a manufacturing tolerance. So it's this little device right here. And I'm going to go grab the valves that I'm going to be using in this head, move the camera, and then show you guys what we're doing. Be back in a second. Actually on the wall over there.
Okay.
You can plug in, and then we're just going to plug in the hot plate. All right, so all right, so as I said, we're using an AV and V valve in this one, and it is a let's get this plugged in. I don't want it to get too hot too fast, so let's put it down on medium. All right, now our heads are heating up. Move that away because it can be kind of noisy. All right, so we're using a gas nitrided stainless valve from AV and V. I like them because they've got a nice wide surface here. Remember I mentioned how wide I'm going to cut the seat to help keep the engine cooler. And we're using inch 900 and an inch 570. Give you a comparison of the difference in size here, right? So I've got several different length valves too. So some of this is when you're machining it, you don't know exactly how deep the factory had machined the seat originally. We're going to run an EV27 cam. If you reference the video I did a while back on how TDC lift is important when you're setting up heads. So I know what the TDC lift is of the EV27 cam, and that is what tells me how close the valves can be on the seat so that they don't hit each other at TDC of the compression stroke when they're overlapping, right? So I have multiple lengths of valve stem here. So once I do the heads and I get the seat exactly where I want it, my valve stem protrusion exactly where I want it to keep the valve train geometry perfect, then I will measure what that valve to valve is on the seat. If I think the valves are a little too close, then I'll pull that valve, I'll move to a shorter valve stem, and then machine the head a little bit further with the shorter stem, keeping the valve stem protrusion correct, but getting the valve further in the head, so our valve to valve is good. So this is again what they call a comparator gauge. Brakes over. Kickstarter, that's funny, Bill. Actually, this bike does have a Kickstarter on it. it's a 5-speed with a kicker. That'd be pretty cool. Connection good for everybody. Yeah, David. Sorry, man. I think it's just you on that end of your feed. All right. So with this little fixture, I think everybody can see that. What we're doing is we're taking two identical valves, both intake valves. We slide this into our setting fixture here. And again, so much of this stuff is touch. And for example, what I'm doing is basically averaging these two valve stems. All right. And if you can imagine, again, we're working in tenths of a thousandths here. I guess everybody can hear me okay. So we're working in tenths of a thousandths. How tight you tighten down that clamp can make a bit of a difference. So it's, you know, you tighten it down basically till it stops. I like to back it off about 1/4 of a turn. That gets me between an 1/8 and 1/4 of a turn is about where you want to be. All right, and the valves are still, that one's a little loose, so let's tighten it down a little more, back it off about an 1/8. Okay, we're good to go there. The next thing is I'm calibrating this. This is a valve guide tool. They have different sizes, and I believe I need to change mine. Yeah, so I need to change this out. So about the heads that I was doing on the shovel head, shovel heads have a 3/8 valve stem. So I changed the pilot out when I was doing the shovel heads. So I need to change this pilot because I'm using a 5/16 stem for these. There we go. See, just a pilot. All right, now, again, these gauges are very, very sensitive. This thing reads down to 2/10 of a thousandths. So if you see right there, each one of these tick marks is 2/10. So pretty accurate, needless to say. So the idea is to, basically we're just calibrating it in. All right, now one of the tricks, remember the touch, the feel, the technique is a big part of this. So we know when we're going to be sliding it in there that we're going to be moving it around and tilting it and all of that. So it's the setup side of this is very important. So I'm setting it up to achieve basically the highest number that I could possibly see regardless of how I spin and move this thing. And I'm doing it on 2 axes. If you notice, I'm going up and down, and then I'm going left to right. I want to make sure and there we go. So the idea is that when I rotate it back and forth, I know you probably can't see the gauge, but I'm dead on 0. So what that means is in the average between these two stems that I'm dead on 0. So now what I want to do just to confirm that is I'm going to measure each stem individually. Yep, we're on the money. All right, I'm going to measure each stem individually just to verify that we're good. I know I probably am. And 310.5. I'm good on that. 10.5. Perfect. We're dead on the money. All right. So I'm set up for the intake valve at this point. When I get to doing the guides themselves, I will repeat the process and for the exhaust. So that's how a comparator gauge works. It's actually not too dissimilar to how you set up a dial bore gauge to do the cylinders. Now, since I have to do the cylinders today as well, let me check the temperature on these heads and see how hot we are. There is a particular temperature that I am looking for, and for that we use a little Raytech infrared gun. Now, I'll tell you another thing about using these as well. If you have a real shiny surface, your temperature will not be accurate. So you have to find a spot that's dark in color and not reflective so that you can get a proper reading. So we'll shine down into the port, see where we're at. We'll come over here. We're only at about 120 degrees. Surface of the head. We're going to measure in several places. Yeah, right at where the rocker box would bolt, we're only at about 125 degrees. So we need to let these sit a little longer. Okay. Since we're going to continue, let's go ahead and I will show you guys. We might as well go ahead and set up some fixtures and such. I know I've got to bore the cylinders anyway. So let's go through the process of just measuring the cylinders where they're at, taking a quick look to see how much taper is in them. We'll set up a comparator gauge on the dial bore gauge. That's going to tell us essentially how oversized we're going to have to go. I believe a 10 thou oversize is going to get us where we need to be. An Evo standard bore size is a 3.498 inches. So if we were oversized, would be 3.508 if 10 thou will work. I'm hoping it will. I'm going to check comments real quick, and I'll show you how we set up dial bore gauges. Denise Hughes, thank you. Nice shirt. I am wearing a Jim's General Machining t-shirt. Isn't that wonderful? I love that company. All right, now let's go to the cylinders. You'll notice again, Miller's did a wonderful job on these. They look absolutely fantastic. All right, and on the base here, I have already, before I sent them out to powder coat, I've already put the base. This is very important. I've already put the base. Actually, use lapping compound is how I do it. As long as they're relatively flat, then put this down like this and use lapping compound to prepare that surface and make sure it's flat. I've also indicated this in as well to make sure it was flat, but now we're not going to assume it's perfect because this did have to bake in a powder coating oven at around 450 degrees. That being said, it can change shape a little bit. So before I start boring and honing, I'm going to put this in torque plates, measure it again to make sure we're nice and square. So, and if we're not, then I would put this back onto the lathe in a mandrel, and we would cut this surface down a little bit. We would square it up to this surface and make sure it's good and square. And then I would have to change my head gasket thickness to achieve proper compression ratio and also to get my proper quench clearance piston to head. So let's hope we don't have to do that again, because these are pretty good and straight. Now let's take a look on the inside of the cylinder. You can see it's got some glazing going on, especially now. You can't pay attention to the color too much. Remember, this was baked in an oven at 400 and some degrees, so that's going to change the color a bit. But if you look down there, you can see we do have a bit of taper in the cylinder down there toward the bottom. I think you guys can see that one spot right there. And as we rotate it around, you can see we have a little down there at the bottom of the spigot, and we work our way around. So we know we are a bit out of round on this one. The other, let's take a peek at this one. And you can see it. There we go. See the different patterns in there. So we know we're a bit out of round. So, all right. Before we start measuring this, any questions real quick, or can I keep rolling? Thanks, guys, for being patient and fastidious. Thank you, Mick. Thank you very much. All right. So I'm just going to take a quick measurement to see where this bore size is at. It looks like it might be a little oversized already. Down a rag so we don't damage our powder coat here. And let's see where we're at. Like I said, for a stock bore, we're looking for 3.498. And we have in that spot 3.499. So obviously this is not a ridiculously accurate way to measure a cylinder, right? We know this. I'm just doing this to get a general idea. And then I'll show you how we get that really good measurement when we set up our dial bore gauge. 3.498, awesome. We're dealing with a stock bore on that one. I'm not going to concern myself with taper at this point because I know this isn't very accurate anyway. But looking at the condition of the cylinder as it stands right now, I should be able to go 10 thou oversize and it clean everything up. So that's very good news. All right, I think we might have one here that's either in really bad shape or it has been bored before. This one is 3505. So let's take another measurement. Of course, that was in the spot where I can see where we saw that glazing. But at 3505, that puts us 7 thousandths just to touch off into our 10 thou oversize, leaving us only about 3 thousandths to clean up on the hone. So this is one of the reasons we measure. Okay, on that side of the cylinder, we have 3498. All right, let's measure that one spot again where we had most of that wear. Yep, and we have, in that one spot, we have 3507. See? So what I'm going to hope for is continue, I'm going to hope we're going to continue on with it as a 10 thou oversize. So I'm going to bore it, but when I bore it, we're going to have that one spot. It's going to be really, really close. It's only leaving me, 3 thou to clean up, basically. to be at a 10th thou oversize. So I've got to considering stone flex and cylinder flex and such. So fingers crossed that the 10th thou will get it. If 10th thou doesn't get it, then I'm actually going to mark this cylinder as number 1. I'll bore and hone this one first. If it doesn't clean up, get a perfect crosshatch, come out round, square, not barreled or anything. We want it perfect. If it doesn't, then I'm going to have to step this one up, and we'll just have to do a 20 thou oversized, unfortunately. So let's show you how we set up the setting fixtures to measure these. Sorry, I normally only do one step at a time, so stuff's piling up on my workbench here. All right. So here we have another, I think everybody can see that. Yep. Here we have another setting fixture. And again, this is all about comparator gauges. So I'm going to set this using, first off, a 3-inch standard, because we're starting with a 3-inch. That's a 4-inch standard. Got a 3-inch standard, so 3498, but we want to go 10 thousandths oversized. So this will tell me how much I need to remove from the cylinder in order to achieve the 10 thou oversize. So we're going to set it to 49. Oh, so you start with 3498. So then you would have 3508. So we'll go to 3.508. All right, 3.508, and just so you know, this setting fixture goes down to 1/10 of 1 thousandths. All right, and again, I also mentioned touch is important, right? Touch is really important. I don't like to just push this here. Any little impact, any little thing can change that dimension, because again, I want to be within a 10th. So what I'm going to do is loosen this up. You also have what's called backlash, since you have backlash in gear mechanisms and things like that. Yes, they are ultra precise, but it's precautions, right? Perfection is what we're after. So we make sure these surfaces are clean, and I'm going to push against it. I'm going to back off and then sneak back up on my measurement. And then we have 3508 on the money. Let me grab my dowel board gauge. Change our. Yeah. So the way this works, you have a very small tool steel ball right there, and then you have the same right there, that little tiny part right there, and so you can get pinpoint measurements. And of course, it's spring loaded. Number 4. Different anvil. Since I'm talking, we're going to check the temperature on our heads one more time. I don't want them to get too hot. All right, still not quite there yet. Okay. Now the idea with this, remember we dialed in our measurement. Move this up so you guys can see. We've dialed in the measurement here. So the goal with this gauge is to set it to 0, so that I know if I drop this into the cylinder, I'm exactly at 0 relative to the dimension that I'm after, which is 3.508. And then the gauge will show you your plus or minus in tenths of a thousandths. And we're dead on 0. Now, the other little demonstration I want to do for you is to show you the difference in a measurement in or out of torque plates. All right, so we're going to take this cylinder. Let me see if I can get the camera in here real close. And I believe we're working with the one that, yeah, this was the questionable one. So, you should be able to see the gauge. All right, so let's start at the top, see where we're at. All right, so at the top of the cylinder, let me raise the camera a little bit. All right, we're right at 10 thousandths, so we need to remove 10 thousandths from this cylinder to achieve our bore size. Let's move down a little. We're at 9 thousandths. Down a little more. 9 thousandths. 9 thousandths. Let's come back up to the middle. 9 thousandths. Top, we're at 10. Let's rotate it. Make sure it's round. We have 10 thousandths there. And it's not unusual, 9.5 there, 9.5 there. It's not unusual on more modern cylinders, twin cam and M8, to see them, to see that factory cylinder in and out and barreled and things like that. So this must be our good one. So we're good to go 10 thousandths over on that one. Now let's move to this one. All right, we're at 9 on the top on this one, but we're still good and in our range. We're at 9 there. 9. 9. You find that bad spot. Oh, right there. Yeah, that's where we're a little off right there in the middle, but I think we'll still be okay. So I've got 9 thou there. 9 thou there. And 9 thou there. There's another reason I want to measure them this way, and then I'll measure them again in torque plates. So when you're taking your cylinder and you're putting it in your boring bar, or let's say you just wanted to hone the 10 thou out, which I wouldn't be a fan of because it's easy to get out of control a little bit. The way the spigots are unsupported, they flex and move. Here they're unsupported, so under tension of the hone they spread a little, and that's one of the challenges of doing these. And not, difference between these and like automotive blocks, for example. So the other reason I do that in multiple axes from bottom to top is I'm kind of seeing how round the original bore is. All right. So if I know this original bore is round, then when it's okay to use that bore as a reference point when I put it on the boring bar to start the boring process. If I found that this cylinder was way out of round in this direction, then I would utilize the torque plate as my reference point, because, see, these torque plates are made to blueprint sizes. So I would use my very tight-fitting torque plate to do it, or I would indicate off of those holes, the dowel pin holes, to find my center of the bore and then bore based off of that. And it's not unusual to find a cylinder that may have been bored before where the hole is off center. It could be 2 to 3 thousandths in some cases. I've actually seen some that are more than that. Where that becomes a very, very big concern is when you're going bigger bores, like say on twin cam to a 3937 bore or 100 millimeter. When you get, that's as far as you can go on a stock twin cam cylinder. So those spigots, this area right here, starts getting very, very thin. And if you're off by, 5 to 10 thousandths, which isn't very much, if you're off 5 to 10, then you're getting very thin on that spigot on one side. So concentricity of the new bore based on the original location of where that bore should be is critically important. So how's everybody doing? Let me check the chat real quick. Hello, Vince, Carl W. How far over can you go before you have to change pistons? In most cases, you don't want more than a 2.5 thousandths clearance on forged pistons. Cast pistons or hyper-eutectic pistons have different clearance requirements. So it could be 0.8 to 1 thou. It could be 1 to 1.5 thou for cast hyper-eutectic, depending on the bore size. Almost all forged are 2.5 thousandths clearance. So if you're beyond that, you really should bore and hone and replace pistons. All right, I think we're still going. Travis, one of our members, hello from South Dakota, sir. All right, so we have this part. Now, let me check temperature on the heads again. And then we're going to file the powder coat off of these. And then we're going to put it in the torque plate. And we're going to measure it again. Remember, all of them were between 10 and 9, except for that one spot in the middle of wear in that one bad one. And we want to see how much that cylinder is going to change shape when we put it in a torque plate. It may barrel, it may taper, but we know we had a starting measurement of between 9, the range of 9 to 10 undersize. All right, so let's check temperatures real quick. All right, we've got about 50 degrees to go, so we have enough time. Thomas, thanks, man. Glad you liked the shovel head video. There's a whole bunch more to come. I got the right one here. Let's check the stud length, see where we're at. Before we do that, we need to file again. File powder coat. File powder coating. All right, cool. Remember, cleanliness is next to godliness, right? See if I have the right, the right plate here. There we go. These actually work for Evo and Sporty as well, so make sure you got them lined up right. Make sure I also have the right studs because they're different lengths. Yep, we do. Beautiful. I'm gonna make sure they're clean. This oil can, my granddad's. How cool is that, huh? Love these things. Belong to my granddad. All I'm doing is oiling this to make sure I get a proper torque. Let's check our heads again. We're getting closer. All right. Grab an Allen socket and my torque wrench. All right. And I just want it kind of, I say hand tight, just a little bit of just to snug it a little, just to hold it in place. And we're going to do a quick visual, make sure we're centered. Now we move to the vise, and we're going to torque it down. Of course, the idea with is we're simulating the torque sequence, torque load when it's actually bolted in. So, comments real quick before we get started. How many people know the firing order of a small block Chevy or mid-60s, late 60s Chrysler? 184, come on guys. The reason I asked that's kind of funny. Basically the torque sequence and torque pattern of an Evo and twin cam are the same when using MLS gaskets. So we're going to be doing that. And those numbers are 9, 14, 22, 35, and 42. So that's going to be the our torque sequence we're going to use here. Cleanliness was next to paycheckness. That's funny, Thomas. I like it. Greetings from Germany. Thank you, Thorsten. Glad you're here, sir. All right, so let's keep going. By the way, anybody answer that firing order question yet? And don't Google it. No cheating. Let's see who the car guys are in here. All right. Now let's go back and let's measure the cylinder again and see if it changed shape on us once we put it in the torque plate. See if we got any comments before I do that. We're moving along. Hey, Mr. Ranlett, you're gonna have a scooter ride here soon. Good day, buddy. Good to see you, Ben. Glad you made it, pal. Mr. Etchel's close guess. 18436572 would be the firing order on both Chevys. But anyway, Francesco, member for 13 months. Thank you, sir. Good to see you. Greetings from Italy. All right, next step. 18436572. Scott and small Chrysler, my man, jumped in there and grabbed it. All right, so now let's measure that again and see where we're at once in torque plates. There seems to be debate occasionally on whether or not you need torque plates for cylinders. Shovel heads up in the air. I've talked to a lot of guys that have been around a lot longer than me. I'm going to talk for a second. That have been around a lot longer than me. Guys like Barry Wardlaw at Accurate Engineering, Rodney Roberts at Rodney's Cycle House in Arkansas. You know, those guys have done a lot more old shovelhead stuff than I have, and so a whole lot more. But that being said, I reached out to them, and they even said the same thing. You know, if there's, they say you should torque plate them to only like 20, 25 foot-pounds, or that's what Harley said back then. 18436572. My man Ben jumped in there and grabbed it. Ben the possum hunter. That's, man, what a story that is. Oh my Lord. I'm not going to tell it right now because unless Ben says I can tell it. It's quite a thing. Ben the possum trapper. He's an expert possum trapper. A lot of guys on the shovel head stuff, since it doesn't have studs that go all the way through the cylinders, some say you don't have to worry about it. Some say you should torque plate them back and forth. When I did, even Rodney told me, don't worry about it, man. Do it and run with it. So when I did mine, I didn't use torque plates on the shovel heads. So anyway, let me grab my bore gauge real quick. And if Ben chimes in, I'll tell you the possum story. I learned something from my friend Ben. Let's check our heads one more time. We're getting close. Yep. We're getting close. All right, dial bore gauge. So now let's measure and see where we are. Well, look at that. Now, if you remember, I want to bring this back up. So, for the naysayers, all right, that say you don't need torque plates for studded cylinders. We remember when we checked both of these, they were basically 10 at the top, right? So if we check this one after in a torque plate, this one we are at 8.5 thousandths. So the top of that cylinder, once torqued, shrank 1.5 thousandths. That's a lot, especially when you consider we're running a forged piston with a 2.5 thousandths clearance. So that's a big difference. So if this cylinder were bored and honed outside of torque plates, fit would not be proper. So now let's check it in the middle. And look at that. We are at 8 thousandths in the middle now. It shrank. Now let's go to the bottom. We are at 8.5 thousandths on the bottom. So this cylinder effectively shrank 1 to 1.5 thousandths once it was in a torque plate. And we'll measure the different axes. Now we've got 9.5 there, and we have 8 there, and we have 7.5 there. So, needless to say, you need torque plates when you bore and hone. That's the reason I wanted to show you guys that. So let's take a break for a second. Since Ben said go ahead and tell the possum story, I got to tell you this story. It's absolutely hilarious. So Ben owns a business called Smith Carriage, and absolutely beautiful team of these unbelievable Belgian horses, man. They're colossal. You can't describe how big these wonderful animals are until you stand next to them. And so Ben and his wife operate Smith Carriage, and he's built his carriages. They're absolutely beautiful, and there's another word for the ones that you use in funerals and things like that, but then he's got a sleigh and all this other stuff. So he's a craftsman. He does blacksmithing and all this type of stuff. So anyway, visiting Ben, it's late one evening, and we're pulling back into his ranch there in his truck, and all of a sudden he jumps out of the truck like wide open, slings the doors open, and Ben's a big man, big man. He jumps out, runs to the barn, grabs the rifle. He's running all over the place, yelling at me to get a flashlight and everything else. And I'm looking around like, dude, what are we? I'm freaking out. What are we doing? It's a possum. It's a possum. And we're looking around everywhere to try to find this possum. Of course, we're friends. I high five it. I jump in, help him whatever he needs, wondering why this possum is such a big deal. I mean, yeah, he's up in Minnesota, by the way. So we have possums down here. We have horses too. I've never thought anything about a possum and a horse. Possums are around here basically just fuzzy rats that can get annoying sometimes. Nobody thinks anything about it. I've never heard anything about it. So we went trying to find this possum. We're tracking it in the snow with flashlight and everything else. Well, come to find out, there's a disease, and I had no idea. And I'm probably making myself out to look like a fool. I had no idea that there was a disease that possums carried in their feces. That if a horse eats it, and it's infected, it's a very slow, painful death. It attacks their nervous system and their brain and such, and it's just a horrible, horrible, pretty much surefire death for a horse. And I think it's called DPM or DPME. It's an acronym, something like that. I don't recall exactly what it was. But after telling me that, I obviously understood the importance of making this possum disappear. And of course, Ben did a fabulous job of uh, dispersing of two possums after he finally got them. So anyway, I've never heard that before. I had no idea that possum feces could do such a thing to a horse. So anyway, there's a quick story for you. I'm gonna check comments real quick, and all right, we're still rolling. We've been on for an hour and 20 minutes, guys. So this cylinder is ready to bore and hone, but I do not want to get started on that just yet. We're going to take the heads. I'm trying to make some room. I normally don't work like this with a messy workbench at all, but I'm trying to do several things at one time here. Normally I just do one thing at a time. Got to be mildly entertaining, right? So we're going to put the valve guides in the heads, and then, which is a really simple process. We're going to put the valve guides into the heads, then we're going to put them in front of a fan and cool down, and while they're doing that, we'll go back to boring this cylinder. And let's see where we're at. No comments? Awesome. All right. Now, I'm going to make some room here because I like to do this relatively quick. All right, so I'm not going to be looking at comments and such, but I am going to get ready to do this process. Let me get some gloves. Let's check the temperature one more time. What did I do with my heat gun? Here it is. Yep, we're there. And we're there. Beautiful. All right. It's going good. We're getting there. All right, as I said, they have been sitting in a freezer, and we're going to move quickly here. Press fit lube. Get them in front of a fan. And move to the next one. Oh, I will show you what we did at least. It's hot though. So there's your bronze guides. And the reason I can hammer them in like that, depending on the type of guide that you're using, you have, man, that's getting hot. I'll be right back. I'll show you this real quick. See the shoulder on the guide? Has a shoulder so it stops the depth. There's also a Viton O-ring on there to keep oil migration from happening around the guide. And there is a different guide for intake and exhaust. Give you a better look. Hold this one for a minute. Nice looking stuff, huh? Like I say, remember, for those of you guys that are just tuning in, the spots that the CNC didn't touch, I'll be hand blending those. And then blending also to the seat for this type of build. That's all that port needed, was clean up on the back of the port and top for what we're doing here. So those will be blended in together. Just like that. All right. You guys have kind of got me running a marathon today. So they're sitting in front of a fan, and they'll be cooling off for the next couple of hours. So I want to make sure that they're, core temperature and everything is down to room temperature, 68, 72 degrees, somewhere around there, so that our clearances will be correct, right, when we machine those guys. So before we load this up into the boring machine, anybody have any questions? Then we'll move to that. Thanks, Mick. Have a good night, buddy. Cheers. Any questions or anything? Nope, we're still rocking. Fantastic. If y'all have any questions, now's the time to ask. I think I am going to move this hot plate. Let's see how hot it is. Too hot for me to touch. A hot plate is actually great to have in a shop, right? And ovens too. I had an oven. One of my guys accidentally knocked it over and broke the glass out of it. And so, I still have an oven that I'll use, but hot plates are great to have in machine shops or even just shop around the house. Anytime you're fitting gears, dropping gears on the cams, bearings, all that type of stuff, a freezer and a hot plate can make your life much, much, much easier when you're doing interference fit type stuff, working on presses and things like that. So there we go. Let's see what we got. Bill Brummett, air chisel or rivet gun? That's basically just an air hammer, but there's a pilot that is used, a driver specifically for a valve guide. You don't just use regular stuff. So it's got a bevel on the inside of it so you don't flare it, and it's a perfect size for it. So it's okay to use an air hammer, certainly, but you just have to have the right pilot for it to make sure you don't do any damage. Daryl, where'd I get my apron? Bare Bones Leather. Look up Bare Bones Leather. Kurt Green owns that place. He is a gentleman and quite a craftsman. So yeah, check out Bare Bones Leather. Martin, still shooting for end of the month on my bike. Yes, I am. Actually, stay right there on that shelf, and then bags right there are your heads. They've already been ported, and that's what I'm doing all week this week is porting heads and prepping cylinders and cases and such. So man, we're doing the best we can, going wide open. Let's see. Paul John, I'll pull guides in with threaded rod. Guide tool helps keep them straight. So you can certainly do that. With the, I'm not sure if you watched the first part of the video where I took all the measurements and things and all of that. So they kind of guide themselves in with how they're tapered and beveled and all that type of stuff, and never had any issues doing it this way. Will I hone the guides to fit? Mentioned that in the beginning as well, Thomas. So they'll be reamed and honed as necessary. And Travis, back to work, catch the rest tonight. Thanks, Travis. See you, buddy. All right, now. Now we move to boring some cylinders. And a lot of this stuff, a lot of the labor, understand that you pay for machine work. A lot of that labor is fixture, setting up machines, you know, all that type of stuff, because it, you know, when you do many type of things that we do around here, there's setup times and all this stuff. Same for anywhere. And even like, you know, if you hire a welder to do things, well, sometimes welders have to make fixtures to be able to do welding projects and such. So that's a large part of it, and some of this is just that. Now, I will show you this. I do like to, you can make some pretty big cuts on boring bars, 30, 40 thou sometimes, depending on how you profile your cutting tool. But I prefer not to do that. I only do about a 20 thou pass at a time, so that's 10 thou per side. It actually helps keep the temperature down. Temperature is your enemy in machining. So what we want is the work, basically the cylinder, to stay as cool as possible. We want the tool, this part, to stay as cool as possible, and we want all the heat to be carried away with the chips. All right, so then your tooling lasts longer and you preserve your work, being the part, a lot better by doing it that way. So I only do 10 thousandths per side on the cut. Well, to do that, I actually like to cut my own profiles on the cutter. Now, there are setting fixtures for this sort of thing, and there's several different ways that these profiles can be cut. I've basically narrowed it down to one particular profile I like, and it does have 3 angles on it, but you have to prepare all 4 sides of the cutter because you have to clear the chips and that sort of thing. So that's what I'm doing now is actually preparing to sharpen my cutting tool. And on the back of this boring bar there is a diamond wheel that spins when you turn the motor on, so it makes it pretty easy to be able to do that. And I'm going to turn this so you guys can see. I think you'll be able to, yeah, you'll be able to see. And then I always use a diamond lapping compound for this sort of thing. Alright, so that's the face angle done. Now we're going to do our two cutting angles. Well, I should say our chip clearing angle and then the cutting angle. And we're going to put about a 20-degree face on it. And overshot it a little bit. Let's go back. Right, fine. Alright, perfect. Alright, so basically what we're doing is we've got clearance angle here, we've got a cutter angle there, you have a chip clearing angle there, and then it's down to a very sharp point right there. That's how it works. one thing I like about this boring bar, since you guys know I came from the automotive side of things many years ago, and I still like to do, let's see if we've got any chat stuff. Why is this called boring? Looks exciting to me. That's funny, Traveler. I like that. This machine is actually really designed. Yeah, Thomas, I'm familiar with Tatro. He's a good dude. There's a cradle over here, and that cradle's wide. It's really big. And what it's made for is there's a long steel rod that you put either through the main bearing or cam bearing journal of an engine block. And then how this works, you can roll that cart over here. This goes away, and you roll the cart in here, and that big rod sits on these uprights. And this air float will pick up the engine block and lift it up to this plate. All right, so then you can take and, do your 4 cylinders or 3 or whatever, and then flip it and do it again. So there's a big airbag down there, and then this, I'm going to show you how we center this into the cylinder. This just floats on air like that, pretty snazzy. But we've got to center it up. So let's do that part. And I'll tell you what, I'll move you guys here. Yeah, there we go. Perfect. Now, we center it in the bore. We're going to be about halfway down. Yep. Right, now, what we do is we float that, and if you remember seeing me change those pins a second ago, there's a, there we go, tapered bar that goes through the middle and pushes out equally on all 3 of those centering pins that are in there. Once we lock that down, well, get it in the middle, and we lock it down, and we're centered in the bore. Okay, now what I want to do, I know we're going 10 thou over, but remember I still need to hone it, because I got to get that cylinder perfectly straight, and I got to get the right crosshatch in it, the right angles, the right RA, RMS, finishes. I've talked about all that stuff. Frequencies and finishes are kind of the same, and amplitude. Anyway, yeah, so that's what that's for. So I need to leave about 5 thousandths. Some people will go 3. I prefer to go 5. Nothing wrong with either way. And I'm only going to bore this 5 thousandths, okay? Because I want to leave 5 thousandths to home. Now remember our measurements that we took. There's going to be some places in this cylinder that the cutter is barely going to touch. And if you listen closely, you'll hear those spots. All right, may hear a that sort of thing as it's cutting. You'll notice a difference. But the other thing I want you to listen for, notice I've got the cylinder in here upside down. That first inch is unsupported spigot. Now I want you to listen closely. You're going to hear the tone of the cutter change as it goes down that 1 inch from that spigot into the cylinder. And what you're hearing is that spigot isn't cutting as much. It's actually expanding a little bit under cutter load. So what will happen is after we do that first pass, we're going to back it back up, bring it to that top again, and then we're going to cut that 1 inch again without changing any setting on the cutter itself. You will hear it cut again. And as it goes further, you'll hear that it's not cutting anymore. So we're trying to, at this stage, get as much of that taper out from that spigot, get it out at this stage so that we're not fighting it when we get to the home. I need some coffee. Now, one of the things I just want to verify that I am in the center of the bore. So I'm going to set my cutter. Remember we're at 3498 was our intended bore size. So I'm going to set my fixture here to 3498, the bore size. And we may just barely hear that cutter tap on one side or another, just a quick type thing. If it does that, then that's telling us basically our cylinder's straight this way, and that we're good on bore size. So it tapping a thou or two is not a huge deal. Obviously we want it to be 0, but just a little bit of a is not that bad. But you have to remember that the cylinder's not perfect either. So anyway, put my old man glasses back on. I'm getting old. What do you guys think about this? This unedited, just doing it live kind of thing? What do you guys think? Just curious. I just think it's one of those things that most people don't get to see this type of stuff. And I think it gives a new perspective when you're able to see this, right? To see all what goes into this sort of stuff. All right, let's see how. All right, now let's see. I may have to reset the cylinder, but we'll find out here in a second. You guys can. I don't know if you want to see me pull levers and such, but anyway. All right, barely touching on one side. I'm not surprised to see that. Let's see where we're at. It's barely touching. You can't even get a fingernail on it. And that spigot's off a little bit. So let's go ahead and make our cut. All right, let's check this one more time. I might reset the cylinder. Let's try it again. No, let's reset it. Now, take two. All right, now let's try that again. see what we got. Now we're in the middle. That's better. Perfect. All right. So you heard how the tone changed, right? So now also we've got a consistent as it's going around. But you'll notice it changes just a little bit. It's hitting all the way around, but that's the different high and low spots. Remember when we measured half a thou plus or minus? But if you notice the tone changed, when it first started cutting, you heard that ringing noise, and then the ringing noise stopped. That's that spigot doing like that. Since I'm only taking a 5 thou pass, there's not that much load on the tool. So that means when I pull it back up, like I said before, you may hear it cut again. We may not. We've got a super sharp tool, because I just sharpened it, and also we're only cutting 5 thou. So you don't get quite as much flex on that spigot because there's not as much tool load. I know I saw a couple of questions that just came through. Let me make sure that I'm good to stop this at the bottom of the stroke, because it's kind of set up to do twin cam and M8 cylinders right now. So let me watch this and make sure we don't have a tool crash, and then I'll answer your question. So hang on just a second. Okay. All right, remember I had mentioned that, remember when we took the measurements, there were a couple of spots that were going to be really, really close, right? In us trying to do, us trying to only go 10 thou over. Well, there's one spot, and if you remember when we measured it, I said we're going to be close. Maybe we're going to have just enough to to clean it up in the home, and I'll show you what that looks like. Otherwise, the bore looks fantastic for what we're working with here. Let's do one more pass just to see if how much tool load we had on the spigot. You may hear it cut just a little from that flex. Hear that? That's just from the tool load. Again, that spigot flexing. It should stop here in just a second. Now you hear it barely even touching. So now that's basically about 1/1000, roughly, a half a thou per side worth of taper that we don't have to worry about when we go to hone it. All right, now what we're going to do is change out to this tool real quick. This is basically just a 45-degree chamfering tool. So we're going to change this out so that I can put a small chamfer on the skirt to make it much easier to get the rings on the cylinder. So let's do that. And this, we can just touch this off and do this by hand because we're not going to put very much on there. Fantastic. All right, now, again, remember the, let's turn this back around. Remember when we measured, I'd set it up to a 10 thou, and to show me how much I needed to cut, right? Remember I said that we were, for those who've been around here a while, I said that we're really close, that it's probably only going to touch off, you know, there's going to be areas that the cutter didn't touch. Me hoping that that 2-3 thousandths I'm going to be able to hit that and blend that in when I start honing it. When I do the hone, if it doesn't at least put a crosshatch and get me round in those areas, then I'm going to have to do this process over again and go another 10 thousandths, right? So let me show you what that looks like. And if you remember, it was at the top of the bore. See right there? So that was that one area that we measured that that bore was getting real close. Now remember, my cutter is set 5 thousandths below desired size. So what we're seeing right there, size, shape, experience tells me about 2 thousandths is going to clear that up, 2 to 3 thousandths. I have 5 to do that on the hone, so we're in good shape. Also, remember the spot on the bottom. And there it is right there. All right. So that's going to be a non-issue. And turn the camera back, or actually, no, let's just check our bore size, just for the heck of it. What I should see, you know, remember that cutter, you know, boring bar is intended to be a rough cutting tool. So then you have this small setting fixture that you use to set it up with. There can be a tolerance there, plus or minus a little bit, plus or minus a half. So don't be surprised if we see, you know, roughly where we should be is it telling us that we still have 5 thousandths to go to get to 0. 5 thousandths underside. We could be off by a little bit. It's not a big deal. That's what the hone is for, to perfect this stuff. So let's get our dial bore gauge. And I like to do this periodically anyway, because that helps me check my boring bar to tell me if it needs to be adjusted. You know, that long of a stroke, if, you know, that spindle come down doing like this, you know, that it could need to be adjusted and dialed in. Well, if my bore is perfectly straight, top to bottom, perfectly round, machine's in good shape, and my setting fixture doesn't have to be calibrated. Alright. And we are on it and square. Perfect. All right, now remember I was estimating. I want you guys to see this for yourselves. So remember this spot at the top here that I had mentioned, that when I look at that, it tells me that I have about, roughly about 2 to 2.5 thousandths, give or take, to be able to touch that off, giving me then another 2 thou in the hone to get the crosshatch in it, right? So that being the case, that one spot where the cylinder was out of shape, if we look, we see exactly, basically exactly that. We're right at 2.5 thousandths. Let me get in the middle of it. There we go. Yep. Let me show you here. I don't know if you guys can see that. So this is your 5 thousandths here, and you can see we're right in the middle at 2.5. So that's about what I figured we would be. Roughly 2.5 thousandths is of a low spot, we'll say, or a high spot. But I can straighten that up in the hone. No big deal. So we go. All right. Any questions? We've been going for 2 hours. What we got? Kyle Davis, 2.5 per side. If you're referring to, not sure 2.5 per side, what, piston clearance or what I'm cutting? 5 thou, yes, 2.5 per side, if that's what you're referring to. Little cutting pressure, it doesn't take much. Brian, thank you, sir. Appreciate you. He says it's one of our best videos. Pins in the head center the cutter. Never used a cylinder boring machine. That's correct. The pins that expands, that expanding mandrel comes down like that, and then pushes those pins out and center it. Edward, you're welcome, sir. Tim, you're welcome. Glad you enjoyed it. Daryl, you're welcome. Kyle, Brogdon 67. Thank you, sir. Appreciate it. Matt was lucky enough to see this in person. This is awesome. Live streams are great. Not editing for you is a win-win. Yes, it is. And I still get to get work done, right? That's the best part. So, yeah, you did get to see it in person. That was a fun day. Mike Farber, yes, sir. And we're just getting started. We haven't even gotten to the valve seat stuff yet. Why don't they make the torque plate thick enough to support the entire skirt? The main reason that I don't like torque plates that support the skirt is because that is not an exact duplicate of what it's like when it's installed in the engine. So when you put it in the engine, that spigot, when it slides down into the case, there's a clearance on both sides all the way around to that too. Sometimes there's as much as 10, 20 thousandths. So I like to cut mine a little tighter. So you wouldn't want to bore and hone in a supported environment only to have it installed in an unsupported environment and see the flex. So there's theories on that it is better to do it that way. In my opinion, the purpose of a torque plate is to simulate installed conditions. I want to reduce variance of installed conditions as much as possible. One way to do that is leave that spigot unsupported. Just my 2 cents. Rob Rich, love it. Nice setup. Great info. Thank you, sir. Great video. Kyle Davis, thank you, sir. Appreciate it very much. All right, so this one is done. The next step is this goes into the hone, but I'm going to check our cylinder heads and see what the temperature is, and maybe we can get started on a valve job. I at least want you guys to see me doing one valve, because if I do one valve, you just have to know that the other 3 are the same, with the exception of the profile differences in the exhaust versus the intake and all that. So if you see one, you'll know what the other 4 look like, and it's 230. So I'm going to slide this into the hone so it'll be out of the way, and let's move to the heads. Guys, do you mind? I tell you what, can we take a 10-minute break? The ladies' room is calling me, and I'd like to get me something to drink. It is exactly, if my watch is correct, it is 2:40. All right, I'm going to take 10 minutes if you guys want to hang out, and I will be back at 2:50, and we're going to move to doing the heads. All right, Thomas, thank you, sir. I'll see you guys back in 10 minutes at 2:50. Oh, and by the way, I'm going to leave the camera right here, so the next 10 minutes are going to be boring. That was terrible. All right, let's move back a little quicker. See, we got any comments or questions before I get started? From No Name, Kevin, it's a lot of great and good mechanics out there, but it's the thing about you. Now, when you mention ladies' room, that shows me how delicate you are with your works. I dream of the day I can bring my bike to you. Thank you, No Name. Appreciate it. Kyle Davis, ha 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 ha. All videos should be done like this. Thank you, sir. All right, let's get back at it, fellas. I'm gonna move y'all around a little bit. I'll do the other cylinder later. All right, now let's grab our heads. But now I can touch them. All right, we want to check. I'm going to give you a little closer look at these also, now that I can have my hands on them. Let's check our temperatures. Beautiful. 71 degrees, that's what we're after. Let's check our actual valve guides. 71. 71. Or 70, 71. Let's see. Yep, 71. $71. And 71. Beautiful. So now we know our clearances are going to be proper in the port. Same. That's crazy. Exactly the same. Yep. That one's 72 inside the port. 72. Yeah, we're close enough. All right. All right, so I'll give you a bit of a closer look. Pretty good so far, huh? Like I said, those little spots right there where we had core shift and we didn't want to make the port too big. I'm going to take, after I blend this on the valve seat machine, cut this throat size right here. We're going to blend that in, and then that'll be perfect. If this was a more performance build, you wouldn't see as much of that on the intake side. It's not unusual to see it on twin cams. You may see quite a bit. Again, it just depends on port size, what's appropriate for the build and all that. So again, we just want to open the top up here and then keep the bottom of the port, get that short turn radius right there, keep port velocity up is what we're after. So I'll go through and hand blend all of that. And for some of you that decide, I'll go ahead and tell you, you know, there are companies that do the CNC porting and stuff, you know, S&S and Zippers and Wards and all these other guys. If they do a set of heads for you and it, you know, it's a good street build type thing, the ports aren't that big, and if you get the heads in and you see some little areas where that cutter didn't touch, don't panic. It's really not a big deal. Companies with reputations like that, like with us, we're not going to produce a head that would have a you know, bad flow pattern or anything like that. So if you have CNC heads done, you know, so it's just because you see the cutter maybe didn't touch in a spot or two, provided everything else is done proper, it's a good reputable company and all that stuff, it's really not that big of a deal. So don't panic. You just don't want to see a whole lot of this inside the port, right? You know, just want to make sure that it's at least blended by hand. Now, I have seen some heads that the core shift was horrendous, and it's not the CNC machine's fault or the operator's fault, but that core, that head, could have been shifted under casting, or the port itself shifted when it was originally cast. So when you touch that off with a CNC machine and you cut it, the port's off from where the cutter thinks it needs to be, so it can be off a little bit. So sometimes you do have to hand blend to get it proper, even if they've been ported, CNC ported. So anyway, and we still do, we do some hand porting and stuff like that as well. It really just depends on the build, and that's kind of the benefit of doing all this stuff in house is I get to custom tailor the builds for the characteristic of the rider, and that's kind of what all this is about. So, all right, let's move to the valve sleeve machine. Just want to check everything. All right, perfect. Let me see where I can set this camera up. There we go. How's that? That work? Everybody see good? That worked for everybody? Position of the camera and everything. You check valve spring pressure and then height after installed. Of course, that's part of the valve stem protrusions, and all springs are checked and calibrated. We're way off from that. We still got to do a valve job, but yeah, we do it with all of them, Bill. Great to see live how it should be done. Thank you, Carolyn. I appreciate that. How was your drink? It was great. It's Coca-Cola. Can't beat a Coca-Cola. All right, remember I had mentioned that there are reamers, solid carbide reamers, specifically for this size valve, specifically for manganese bronze. So that's what I love. These reamers are ridiculously expensive, ridiculously expensive. But the idea is that they leave most of the time, a perfect finish and fit, and you don't have to do any honing. But after we do this, we're going to check it. If you were in the beginning of the video, you would have seen the setting fixture and the gauge that we're going to use to do that. So we're going to ream it and see where it falls. If the finish is good and the fit is good, then quite frankly, there's no need to hone it. Okay. Is the air off? Alright, we might have to... We might end up having to hone that one. Let's check it and see where we're at. Actually, we're dead on the money. Let's check this one. Oh, it's got trash in it. That's fine. Take a close look at our finish, and then we'll take a measurement and see where we're at. We may have to hone that one because the air compressor didn't kick on right in the middle of it. Now, let's see where we're at. So what I'm looking for is 8/10. Well, excuse me, I'm looking for 8 on the intake side. So the way the AV&V valve works, let me make this Brian. Yeah, I have been. What I've been whistling is the scene with the scarecrow, his little song. If I only had a brain, I would dance and be merry. Life would be a thing of dairy, whatever he says. If I only had a brain. So the way the AV&V stuff works, you notice I had mentioned that we have different clearances between the intake and the exhaust stem, but I use the same reamer in all 4. I'm surprised nobody's asked that question. So the way that it's done, AV&V actually sizes the exhaust valve stem 4/10 smaller than the intake stem. So that's where the extra clearance comes from. So if they all measure the same here, then knowing the stem is 4/10 smaller, that's where the extra clearance comes in. That means you only have to have 1 reamer to do this. So anyway, we're going to check those exhaust stems anyway. So what we have here is, let's see. Dead on the money. Money. And we are dead on. Sweet. All right, now, any questions? All that makes sense? If I only had a brain. Thank you, Camille. I appreciate that, sir. Wanting to know if you can support the channel from Europe. Thank you. Kyle Davis, are the valve seats cut half degree different from valve then lap? Yes, absolutely. We'll get to that. All right, let's keep going. Like I said, I'm only going to do the intake side because all the rest of them are the same. And then I'm going to sign off and let you guys get back to your day, and I'll keep working. What I'm doing here is just leveling the platen. So in the y-axis, leveling it to the head, or the guide, so it's perpendicular to the cutter. Lock that down. Now we've got to get it in the x-axis. I'll be scratching on my head. I'll be scratching while my thoughts are busy hatching. If I only had a brain. All right. Oh, there's a bag of microfibers around here somewhere. I just had one earlier. Got one? Oh, thank you. All right, here we go. Just the right amount of shake just to confirm the clearance. We're good. Nice. So the first thing I want to do, check my valve stem protrusion where I'm starting. And I know how much I can basically afford to cut. That's done with this. All right, we're going to start at 35 thousandths and then see where that puts us. I had mentioned I like to use carbide cutters. This can be done with stones and all that type of stuff, but I'm carbide. There's a whole bunch of different profiles that are available. You can see I've got Well, let's see. A whole collection right here, and then I've got drawers full of different profiles depending on how the build's being done. And watching that down micrometer, I can actually see how concentric the seat is. You know, if you have no movement whatsoever in that needle, then you know you're pretty much concentric. Guess what I should do is let you guys see some close-ups of, you know what, I'm just going to keep going, and then what I'll do before I sign off, I'll show you what the original seat looked like versus what we're cutting. All right, so, all right, yeah, that's what we're going to do. Now let's see where our protrusion is. All right, I need to go another 10 thousandths and we'll be on the money. I think I'll be okay also to run the longer valve stem on this. I think we're going to be all right. So we'll go another 10. Man, I can't get that song out of my head. Beautiful, beautiful, beautiful. All right. Excellent. All right. Let's check that protrusion one more time. On the money. Perfect. That's what we want. All right, now what I'm going to do, since when I cut that, we've got a little bit of a recess, so I'm going to do what's called unshrouding. So we're just going to take that rough lip that's left on this particular profile from our top angle and just open that up just a little bit, not much. You can't unshroud one too far, and again, it depends on the kind of build you're doing as to how far you're going to do that, but we're just going to touch it just enough to clean that up. And this is what I say a relatively simple valve job because we didn't have to replace seats or anything. Have to replace seats, you got to cut them out, freeze them, heat the head, all this other type of stuff, and that definitely gets quite a bit more involved. and get me right where I need to be. All right. Now, so what I want to do, put a little die cam on here because I know where my contact patch is. I just want to sneak up to it. I don't want to cut into it. I want to be able to see how wide it is and just unshroud right up to that point and blend it in. I'm going to open that up. I'm going to open that up just a little bit more. I don't like that. It's a bad omen, I think. Go a little deeper. Perfect. All right. Then get out. As I noticed one comment when Matt, one of our channel members, was here on a bench watching me do this stuff, they made the comment, get in, get out, with that cutter. And we'll get it cleaned up and let you guys see what we got here. Now I still have to cut the throat. I still need to cut the idea of the throat, even though it's really close to the port. And then I'll go in by hand and clean this up, of course. All right, and what we're also going to do is I'm going to move the machine. We're going to drop the valve in there. We're going to lap it just so we can see exactly where that contact patch is. And again, this ain't a hot rod build. So what I want and what I hope to see here is roughly about a 25 thou ring on the valve on the lower third. We're not going to put it right at the edge of the valve. That's one way you can build a little bit more peak horsepower. But we're going to put it just in that lower third of the valve. So basically ensuring more longevity and quite frankly, if you ever had to go in and freshen this up way down the road, you've got enough seat and enough valve there that you can still just kind of touch it off. So it's just a way to make them last a lot longer. All right, fantastic. So let's take the camera and let you guys see what this looks like. I'm just going to take it off the. Well, let's see. Yeah, it'll be easier just to take it off of this, I think. Hang on. Unplug the power cord. You guys can see that. Let me get the camera in there. There's that, and that's what a stock one looks like versus that. I think you can see that. Yeah, there we go. So, what do you guys think? Quite a bit of difference, huh? So now let's confirm what we did by lapping it in. The lap is the telltale story of the seat. You find out exactly where it's sitting. All right? All right. I'm just going to get this out of the way for now. And let's see how we did.
There.
Oh, yeah.
Sweet. Keep your ear out for the bugs or something. Gotcha. Thank you. Thank you.
show you the valve here in just a second. Let me wipe all this off. All right, so remember my target area was kind of in that lower third of the valve, not right at the edge, not in the middle, just a little on that lower third. And the seat, where it etched it, looks fantastic. So here we go. See that stripe? And there we go. Yeah. There we go, right at the lower third, perfectly concentric all the way around, and the intake will look just like that when we're done. So, all right, and I'll let you guys see one more time before I sign out of here. Geez, we've been going for 3 hours. Let's see. I think you can see in there pretty good, right? So there's a ring basically right here that's frosted over from lapping. And if I do this, oh, I got a little bit of compound in there, hang on. Got a nice ring to it. You got a little bit of a shake for clamp's sake. And then you can see how the valve is now unshrouded a little bit around that area to help improve the flow there. So, and also I look in the port, make sure I've got no light. And there is none. Of course, I'm going to water test it and then we'll pressure test it, and then when we go to CC the head and all that stuff, that'll be another opportunity to have fluid in it. Make sure we have no leak before we then move on with assembly and all that. And the last step, since we know that this is front intake, we're going to mark this front since we're matched. All right. All right, now let me move this. Okay, there we go. What do you think, guys? I'm going to sign off and I'm going to keep going. You got to see one. The other valves are the same. The profiles on the seats are different, of course. Different cutters, all that type of thing. So just different profiles, and you know the process. Other than that is pretty much the same. So you got to see. You didn't get to see me hone cylinders, but I've got enough videos on cylinder honing. So, interesting part of the process. Now, I haven't taken a whole lot of time to stop and talk. Notice I hadn't stopped. We're 3 hours, 11 minutes in right now, and I still have to hone that cylinder, bore another one, hone that one, do 3 more valves, then CC the head, then move over to the lathe and deck the head. A lot of people don't realize how much time it takes, and then after the head's decked, you got to clean it again. You got to calibrate all your springs. You got to check your spring installed heights. You got to shim them. You got to do all of those things, put your valve stem seals on and all that stuff. So there's still several more steps in the process, so people get a have a little better idea on the length of time it takes to do some stuff like this, right? So I'm going to roll back, see if we got any questions. Rob, thank you, sir. Appreciate you being here. Corey, Matt, thank you, sir. Carrie, Robert, Ed, Joe, Matt, man, there's a bunch of guys in here. Dave, glad to see you. Amos, let's see, cool to see these large machines being used. I like them in shop. They look so complicated. But yeah, they can be. I appreciate it, Traveler. Joe, a few guys still in here. All right, guys, I'm going to bounce out of here and get back to work. I appreciate y'all joining me for this very much, and hope all of you have a great day. Thanks for being here. Take care of yourselves and each other, fellas. Have a good one.